All right, today we're actually going to go on site and go over sandblasting equipment, common issues that people run into, how you can improve production and maximize your efficiency in blasting, some safety considerations, and a lot more. So we're going to go on site, show you a blaster in action, give you a lot of helpful tips and pointers on sandblasting, how you choose to properly prep the surface, determine where you've succeeded or not, and a variety of other things. So let's get going. So today we're going to be covering sandblasting. We're going to go over the equipment options that you have, important facts to consider to ensure maximum production, and some of the common issues that you run into with blast equipment. When it comes to blasting, the three key factors that determine your production are the blast media type you use, the volume and pressure of air that you have available, the size of your blast nozzle, and what you're blasting off of the surface. The main factor that determines production is volume of air. That's labeled in CFM and is usually a fact dependent on the size of horsepower of your compressor and the design of your compressor. So for example, in this situation, we have a two-stage design compressor, and it's a 375 CFM compressor. Blast nozzles can take anywhere from 100 up to a few hundred CFM of air. If you don't have proper volume of air, your blast media will not be properly and effectively delivered to the surface of what you're blasting. The pressure and the amount and size of media, as well as that hits the blast surface, is what's going to matter as far as removing contaminants quickly and efficiently. To ensure maximum production, you want to try to find the largest compressor that you can feasibly accommodate, and you want to make sure that your hose is efficiently sized for your blast system, including the piping on your blast unit itself. Small hose restricts airflow from the compressor to the blast nozzle, and that for a general rule, for every pound of pressure loss at the nozzle from the compressor, most compressors provide 120 pounds of pressure, and then the volume of air is needed to deliver the media and air to the nozzle. For every pound of pressure loss, you lose about 1 to 1.5% of production. We actually used a needle gauge, which I'll show you in a moment, on this nozzle, and at the tip we're getting 90 pounds. The compressor generates 125 pounds of pressure. Part of the reason that's occurring, we do need to go with a larger airline size. The best way to size an airline is to consider both to the pot for your compressed air, to the pot, and then from the pot to your nozzle, is to try to use a hose that is at least 3 times, preferably 4 times the size of your blast nozzle opening. So if you're using a 5/16 inch nozzle, you would want to consider a 1.5 to 2 inch airline. What that practically gives you is the ability to maintain high production, because it will reduce the amount of pressure drop and air volume that you lose as the air is sent to the blast pot and then out to the nozzle. Large hose can be hard to handle, so you can use a smaller hose at the very end of your hose for the last 10, maybe 15 feet of hose. We call that a whip line, and that'll allow you to maintain the airflow as efficiently as possible, but give you a small air hose to work with at the end of the line, so it's easier to manipulate. Important safety equipment for sandblasting include a blast hood that is NIOSH and OSHA certified, like the one we use here. This is a force-fed hood. You can use these either with your air compressor, which if you do with their standard compressor, you'll need a carbon monoxide monitor to safely ensure that you're not sending any carbon monoxide to your operator. Additionally, if you don't use a high pressure or respirator, you can use a low pressure respirator with a free air pump, which stands off to the side on its own. You'll want to make sure that pump would remain far away from the blast site. The benefit to that is you do not need to have a CO monitor if you're feeding your blast operator with a free air pump. You can see the air comes from the compressor out to the pot, connects to the pot. As the air is enters the pot, it allows the pot to seal and closes off the exhaust valve, pushing air and media to the operator. When you adjust the pot, there's a valve at the bottom we'll show you here, and the goal is to adjust media so it just slightly tints the blast media airstream. Too much media in your airstream can slow down your production, but too little media and you won't have any work done. You want to hold the blast nozzle 6 to 12 inches away from the surface of what you're blasting, and you want to stay as directly over the target, much like you see here, as possible. Angling side to side can cause the media to ricochet, reducing time and reducing your production ability. You want to move in a slow, steady pattern, and you'll ultimately need to decide what your profile goal is and blast so you think you're near to where you need to be. You can use the surface comparer tool to see various profile estimates, and then ultimately, for a best option, use a gauge or a tape to measure the actual profile. We'll show you a surface gauge so you can understand what we're talking about there. Another important safety component is an airline filter, like you see there. And what that allows you to do is to purify the air of any water or oil. It won't clean carbon monoxide, but it'll clean water and oil and keep your operator from getting any of that inside of their mask. The filters inside that unit are meant to be changed anytime you sense an odor, significant water is filled up, or every 3 months, depending on use. You also want to regularly check all your air hoses to make sure they're properly working. You don't want to see any bulges in the line. You don't see any in this line. You want to make sure that your connections are in good working order. You want to check your nozzles every couple uses to see if they're wearing excessively. Most blast nozzles will start around 200 to 300 hours of use before wear is too excessive, but certain nozzles can get anywhere from 500 to 1,000 hours of use if they're made of silicon or boron carbide, respectively. The size of your blast pot will be, along with the size of your nozzle, will determine how long you can blast before needing to refill. When selecting a pot, you want to consider a blast pot that will allow for 20 to 30 minutes of blast time prior to needing refill. That'll be based on the size of nozzle you intend to use and the volume of work. This is a 3 cubic foot pot. You can also get 6 and 10 and larger. A 3 cubic foot is about as large as you would want to use for regular maneuverability on a job site. 6-pound pots can be moved, but they're relatively cumbersome. A 3 cubic foot pot or a 6 cubic foot, no matter what size pot you use, shouldn't be moved when full for safety. You also want to check to make sure that you have clamps on all your airline. Between couplings, you should have safety connections, and in between lengths of hose, you should have safety connections that connect the hose back to the other hose that you're connecting, so that in case of a failure of your connection, you won't have any line going loose. We have a safety handle called a dead man trigger. You always want to make sure that that's properly functioning and in good condition. The way it works is as you press the lever, air is sent back to to the blast pot from the safety handle, causing the pop-up valve to close, sealing the pot, and also allowing air into the pot and closing the exhaust valve. That's for a pressure release design. For a pressure hold design, there's actually a manual valve that you open to allow air in, and one that you close to close. And then the air creates pressure on the valve at the bottom of the pot, allowing it to open and allow media and air to flow. A pressure hold blast system is ideal for frequent starts and stops, or as well when you're using multiple blasters. If your hose is much over 100 feet in length, you would not want to use an air safety handle, or dead man trigger as we call it, like in this video, but would want to consider an electric remote. Electric safety handles are more responsive and will prevent any issues or delays in the blast pot depressurizing if your operator happens to drop the handle. Routine maintenance things to consider on the blast pot: you should always consider to empty the pot of media in the line as well when finishing a job, so that you do not have media back up in the line and form clumps or pack out in the bottom of your blast pot. You also will want to inspect your hoses to ensure no lumps or nicks have occurred to them. You want to check your cartridge and your air respirator filter to make sure that it is not blackened or containing excessive moisture. Both would indicate you may need to change the filter. We'll walk over the blast pot so you can see the concept of how it works. You see here, it has a filter to keep the air pure to the pot. If you don't have that, you can send too much moisture into the blast pot and create media and cause the media to pack out. Other common routine maintenance on a blast pot include emptying the abrasive trap screen, which prevents blast media from getting into your exhaust valve and ruining any of the components in there. You also want to routinely check your exhaust valve for wear and your inlet valve for wear. As you see, he's standing directly over the part a few inches away and blasting straight at the target. That's the most efficient way. And as you look at his media stream, it's mostly air and only a slight bit of media. And that's the most effective way to blast. We'll give you some info on blast media as well, so you can understand how that contributes to your production in blasting. Anyone in the area should be wearing a respirator so that the dust created from blasting does not negatively impact you. Abrasive blast dust can be hazardous and dangerous. Depending on what you're blasting, you may need to test the surface for any contaminant prior to your blast work to ensure that you have proper procedures in place to get rid of the media and to protect you as a worker in the blast area. If you're at all wondering about production and what's causing your production loss, this is a pressure gauge that you can insert about 6 inches away from your nozzle holder on your blast hose. During blasting, it'll give you a pressure estimate at the tip of your nozzle. It's common knowledge that to blast steel, you need around 90 pounds or greater for the majority of structural steel work. If your nozzle pressure is less than 85 pounds, you typically are going to lose significant production, and are usually not using a large enough hose to properly feed your blast nozzle efficiently. You want to also routinely check your nozzle holder to ensure it is not worn when you're checking the top blast nozzle itself. common issues that can occur. If you find you're not getting any air or your line's chugging, that could be a sign of low blast media, not enough pressure in your blast line, or a plug in your hose. To undo the hose plug, you can disconnect it and slowly elevate from front to back the hose until media or whatever is blocking the line may come loose. If you notice your pot not pressurizing, then most likely is your inlet valve, outlet valve, or a pop-up that isn't effectively sealing. The inlet and outlet valve can be replaced or rebuilt, and the pop-up valve has a seal underneath it that allows the pot to close. When it comes to adjusting your blast pot, it will depend on the type of valve you have. This is a standard flat sand valve meant for expendable media. To the right is fully closed, and in the middle is open. You always want to start with the valve fully closed, and you want to slowly begin cracking it. And what you want to look for with your blaster at the tip is that your air you will either hear a whistle, and you can go a little bit past the whistling, or you want to see the air in the blast line turn a slight discoloration, not a significant change, but just a light tinge showing that there's some media. Excessive media will slow you down. So that's kind of how you adjust the blast pot. Another important thing to consider about blasting is that pressure is not always good. If you're blasting soft surfaces and aiming to just remove a coating, you may need to use a softer blast media and lower pressure. For example, with the car, you may only be using 30 to 45 pounds of pressure with a very fine glass media or even baking soda. If you have concerns over changing the surface because of blasting, you want to start with the pressure low and gradually increase until you're removing the coating or contaminant without making any changes to the surface. If dust is a concern for your blasting, you can get a water injection nozzle, around $150, or you can consider a wet blaster, depending on the volume of dust reduction you need. A wet blaster reduces dust significantly more, but is also much more expensive. These are some of the important things to know about blasting, and as you watch this technique, we hope you found this helpful. So once you're finished blasting, you're going to want to ensure that you've blasted to the proper standard. There's a variety of standards when it comes to blasting, from brush off to commercial to near white and white metal finish. Depending on your job, you will need to achieve a different profile, and that will be based on the spec that your job is calling for. The quick way to visually gauge how blasted a surface is to use a visual comparison. You can get a visual comparator from organizations like Katie Tater. You can also just simply look at it and use a basic chart like this, so you can see near white and white. Near white has some darkness, commercial has a lot more darkness. If we're looking visually at this surface, you can see it's primarily all white. So I would consider this to be a white metal or near white metal. You can also use a surface gauge measuring device, and you will want to do this. It'll record the profile that you've achieved. Some options include test X tape that will be laid on the surface and pulled up to show the profile on the surface. You can also use a digital gauge, and the key is you want to take readings in a few different spots on the part. That'll give you an idea of the profile you've achieved, and that's something important to mark down in any of your jobs so that they know the quality standard that you met. Obviously, the white metal blast takes the longest and is the most thorough, and then as you drop down a brush off to your lightest blast profile, we'll have a link to an article for you to read on how to show the difference between them. That's a brush off. A lot of your mill scale is still adherent. Commercial, you'll still have some. Near white is very little left, and then white metal is your cleanest standard. The bigger the nozzle, smaller media, the higher pressure, the more air, the faster you'll be able to achieve your profile.